High above the clouds, there is an aircraft that challenges the basic rules of detection and defense. It moves across continents, carrying enormous firepower. Yet many radar systems struggle to even notice it, known around the world simply as the B-2 Spirit. This stealth bomber represents one of the most advanced engineering achievements ever created by the United States Air Force. Unlike traditional bombers that rely on speed or heavy armor, unseen, its strange flying wing shape, special materials, and hidden engines allow it to slip through heavily defended airspace where other aircraft would be detected instantly. But creating an aircraft capable of this level of stealth required decades of research, billions of dollars, and some of the most secretive engineering projects in aviation history. The idea for an aircraft like the B-2 did not appear overnight. During the later years of the Cold War, military planners realized that new radar networks and missile systems were becoming extremely powerful. Traditional bombers that once dominated the skies were suddenly at risk of being detected and destroyed long before reaching their targets. Engineers needed a completely different approach to survive in such dangerous airspace. Instead of building faster bombers, scientists began studying ways to make aircraft extremely difficult to detect in the first place. This research eventually evolved into modern stealth technology. The goal was simple in theory, but extremely complex in execution. Design an aircraft that could approach enemy defenses without appearing clearly on radar screens. One of the first things people notice about the B-2 Spirit is its unusual shape. Unlike most aircraft, it has no tail and no clearly defined body section. Instead, the entire aircraft forms a smooth, curved wing stretching wide across the sky. This design is called a flying wing configuration, and it plays a major role in reducing radar visibility. Radar systems work by sending radio waves into the sky and detecting the signals that bounce back from objects. Flat surfaces and sharp angles reflect these signals strongly, making aircraft easy to detect. The B-2 avoids this problem by using carefully angled surfaces that scatter radar waves away from their source, preventing strong reflections from returning to enemy sensors. Stealth technology is often misunderstood as making an aircraft completely invisible, but the reality is more complex. What the B-2 actually does is dramatically reduce what engineers call its radar cross-section, the amount of radar energy that reflects back toward detection systems, even though the aircraft is physically enormous. Its radar signature can appear far smaller than expected. This is achieved through a combination of design, coatings, and internal structures. Special materials absorb portions of incoming radar energy instead of reflecting it at the same time. The aircraft's smooth surfaces redirect much of the remaining energy away from radar receivers. Together, these techniques make the aircraft extremely difficult to track. Another secret behind the B-2's stealth capabilities lies in the materials used to construct it. Much of the aircraft is built using advanced composite structures rather than traditional metal. These composites are lighter, stronger, and capable of absorbing certain types of radar signals. Layers of specialized coatings are also applied to the outer surface to further reduce radar reflections. Maintaining these materials is incredibly important, which is why the bomber requires extensive inspections after missions. Technicians carefully repair even small imperfections in the aircraft's coating, because any surface damage could potentially increase the aircraft's visibility to radar systems. Inside the B-2 are powerful engines that allow it to travel long distances and carry heavy payloads. However, these engines are positioned deep within the aircraft structure rather than being mounted openly under the wings. This placement helps reduce both radar reflections and infrared heat signatures that enemy sensors might detect. The airflow from the engines is also carefully managed to mix with cooler air before leaving the aircraft, reducing the heat plume visible to infrared tracking systems. These subtle engineering details play a crucial role in allowing the bomber to operate in environments where detection could otherwise be inevitable. Range is another major strength of the B-2 Spirit, designed for global operations. The aircraft can travel extremely long distances without needing to land with the help of aerial refueling tankers. It can remain airborne for many hours and reach targets thousands of kilometers away. This capability allows the bomber to launch from bases far from conflict zones while still reaching its objectives. Such flexibility is a key advantage in modern military strategy, allowing missions to be planned without relying on nearby airfields that could be vulnerable to attack. In modern warfare, Navigation systems can become targets themselves. Satellite signals, such as GPS, may be jammed or disrupted during conflict to ensure reliability. The B-2 was designed with multiple layers of navigation technology. Advanced inertial navigation systems track the aircraft's movement with incredible precision, allowing pilots to determine their position even without satellite guidance. Radar mapping systems and onboard sensors provide additional confirmation of location and direction. These redundant systems ensure that the bomber can continue its mission even if electronic warfare attempts to interfere with its navigation tools. While stealth allows the B-2 Spirit to enter hostile airspace undetected, the aircraft's real purpose lies in what it carries inside its massive internal bays. Hidden within the center of the aircraft are compartments capable of holding an extraordinary variety of precision weapons designed for different types of missions. Instead of attaching weapons externally, like many fighter jets, the B-2 stores everything internally to preserve its smooth stealth shape. This bomber can carry dozens of precision-guided bombs capable of striking strategic targets with incredible accuracy. Some of these weapons are designed to penetrate deep underground structures, while others are optimized for destroying hardened facilities or infrastructure. Because the aircraft can reach heavily defended areas without early detection, its payload becomes significantly more effective than that of conventional bombers. Creating the B-2 Spirit was not only technologically challenging, it was also one of the most expensive aviation projects ever undertaken. Developing stealth technology required years of experimentation, specialized facilities, and entirely new manufacturing techniques by the time the aircraft finally entered operational service. Each unit represented an investment of hundreds of millions of dollars, and when the cost of research and development was included, the total price per aircraft rose dramatically. For this reason, only a small number of these bombers were ultimately built. Although the original plan envisioned a much larger fleet, global political changes after the end of the Cold War reduced the need for such large numbers. Even so, the aircraft that were produced remain among the most advanced strategic bombers ever constructed. Chapter 10. From the outside, the B-2 appears enormous, but the cockpit itself is surprisingly compact. Inside the front section of the aircraft sit two pilots responsible for controlling one of the most complex machines in aviation. The cockpit is filled with digital displays, navigation systems, communication equipment, and mission controls that provide constant information about the aircraft's status during long missions that can last many hours. The pilots must carefully monitor every aspect of the aircraft's performance while coordinating with ground command and aerial refueling crews. Despite the bomber's sophisticated automation systems, the human element remains critical. Pilots undergo extensive training to handle everything from navigation challenges to unexpected technical problems while flying thousands of meters above the Earth. Operating such a sophisticated aircraft requires far more than simply fueling it and sending it into the sky. The B-2 demands an extraordinary level of maintenance to ensure its stealth features remain fully effective after many missions. Teams of technicians inspect the aircraft in specialized facilities designed to protect its sensitive coatings and materials. Even minor imperfections on the aircraft's outer surface can potentially affect its radar signature, so repairs are carried out with incredible precision. This process means that a significant amount of time is spent preparing the aircraft between flights. Although this maintenance requirement is demanding, it is essential for preserving the stealth capabilities that define the bomber's effectiveness. Unlike many other military aircraft that frequently appear in public operations, much of the B-2's activity occurs quietly and without widespread attention. When these bombers deploy on missions, they often travel enormous distances from their home bases, sometimes crossing entire oceans before reaching their objectives. Because of their stealth capabilities, they can approach targets that might be extremely difficult for other aircraft to reach safely. Over the years, the bomber has been used in several strategic operations where precision strikes were required against high-value targets. However, many details surrounding these missions remain classified, adding to the aircraft's mysterious reputation. Technology never stands still, and even groundbreaking aircraft eventually inspire new innovations. Engineers are already developing the next generation of stealth bombers that will build upon the lessons learned from the B-2 Spirit. One of the most anticipated aircraft in this new generation is the Northrop Grumman B-21 Raider, which is expected to incorporate improved stealth features, modern electronics, and more efficient operating costs, while the B-2 continues to serve as a powerful strategic platform. Future aircraft will likely take stealth and long-range capabilities even further. The evolution of these bombers demonstrates how rapidly aerospace technology continues to advance. The B-2 Spirit represents more than just an aircraft. It symbolizes a remarkable era of engineering ambition and technological innovation. Every element of its design, from the smooth flying wing shape to the advanced materials covering its surface, was created with one purpose in mind: to operate where other aircraft could not decades after its introduction. The bomber still stands as one of the most recognizable examples of stealth technology in aviation history. As new aircraft eventually replace it, the influence of the B-2 will remain deeply embedded in the design of future military aviation. It is a reminder that sometimes the most powerful machines are not the ones that move the fastest or carry the largest weapons, but the ones that can move silently through the sky, unseen until the mission is complete.